And we're back. Right? Since I didn't look in the mirror. There we go. Good evening, everybody. It is Sunday. It's day 6 of Advent of Code. And my name's Kent Quirk. I am solving Advent of Code problems, typically in Go. And I haven't looked at them before I start the stream, so you get to see me solve them in real time. And make my camera not as lopsided as it was. Hold on. How's that? It's better. So yeah, I am a software engineer, engineering leader. I have been doing software engineering since I was, been paid for it since I was in college, actually. And I've been doing it roughly 40 years. So I'm, it's kind of fun to just tackle these interesting computer sciencey type puzzles online and let people watch me do it. Hopefully you'll learn something. So let's take a look at my screen. What you're looking at here is the Advent of Code page. The Advent of Code page has the 5 problems we've already solved. And then problem 6. Now, one thing I'll point out is that I am Kent Quirk at all of the typical social media sites, including GitHub. So if you want to go to GitHub and look at Kent Quirk, you can see the Advent of Code problem sets, and I will always push these problems as part of a solution. So you'll see them up there later on today. The first 5 days are already there. Days 1, 2, and 3 I did in both Go and Python. Days 4 and 5 I think I only did in Go. They didn't seem worth doing in Python. They're pretty straightforward puzzles. So sometimes it's fun to see how much shorter you can make it in Python. But part of the reason I do it in Go and part of the reason I like Go is that I find Go to be very easy to understand and read. When I've built systems, I've very often found that those systems have lived a long time, and it's nice to be able to go back and look at your code and understand what it's doing without it being excessively clever. So yes, here's the Advent of Code puzzle. Here is my command line that I use to, test and run and things like that. And here is an editor that I've opened on a template files that I've already constructed. I just start this by having a template which can read the data files and things like that. I use Visual Studio Code, and we're going to get into it. So let's take a look at what the problem is today and see where we go from there. So, day 6. Now the fiction of our little story this year is that we've been working on going on vacation. So so far it's been getting our way through the airport and onto the plane, and we found our seat yesterday. Today, now we're about to do customs, apparently. Day 6, customs. As your flight approaches the airport, where you'll switch to a much larger plane, customs declaration forms are distributed to the passengers. There's a link to that. I'm going to open the link just to see what it takes us to. Wikipedia page. Thanks, Jimmy. I should probably give you money, but I haven't yet. The form asks a series of questions marked A through Z. All you need to do is identify the questions for which anyone in your group answers yes. Since your group is just you, this doesn't take long. However, the person sitting across from you seems to be experiencing a language barrier and asks if you can help. For each of the people in their group, you write down the questions for which they answer yes, 1 per line. For example, ABCX, ABCY, ABCZ. In this group, there are 6 questions to which anyone answered yes, A, B, C, X, Y, and Z. Another group asks for your help, then another, and eventually you've collected answers from every group on the plane, which is your puzzle input. Each group's answers are separated by a blank line, and within each group, each person's answers are on a single line. For example, ABC, so ABC, and then AB, ABC, A. So this is 5 groups, okay? The first group contains 1 person who answers yes to 3 questions. The second group contains 3 people. They answered yes to 3 questions. Third group contains 2 people. Combined, they answered yes to 3 questions. I see. Fourth group contains 4 people. Combined, they answered yes to only 1 question, question A. And the last group contains 1 person who answered yes to 1 question. In this example, the sum of these counts is 11. For each group, count the number of questions to which anyone answered yes. What is the sum of those counts? All right. So essentially what they're asking is to create a set of values so that you know that are true. So multiple answers to the question are not important. So we need to parse this into our groups, and then for each group we basically create a set, and that set has we just set the value we created true. So a set, just to be clear, is a data structure where it stores the number. It stores a collection of individual values. So and you can't store anything more than once. So Python has a data structure called set. So if you just add items to a set, if you add them multiple times, there's only going to be 1 in the set. That's what we're looking for. We're basically adding items to the set and then counting the size of the set. Now in Go, there is not a separate set data structure. However, a map is a collection of key value pairs, and if you ignore the value, it's a collection of keys, and whenever you try to do something with the key more than once, then you're just overwriting the initial value. So the idiom in Go is that a set is a map whose keys are whatever type you're using. In this case, it'll be a string, and whose values are an empty struct. One of the nice things about Go is that an empty struct takes no space. So it's you can also, I've seen people do things like a set of bool and they just set it to true, or a set of ints and you set it to 0 or whatever it might be, or you sometimes even a set of strings. A map of string to string, and then you just set the map to its own value. I've seen people do that. So all of those are valid, but the one that is most memory efficient is a map of string to, or whatever your key type is, a map of string to empty struct. So this is a trivial problem to solve in Python. So maybe after this is over, we'll go back and solve it in Python if the second half isn't as interesting as, isn't all that interesting. But right now, let's do it in Go just to kind of show how we would parse and things like that. So now we are reading things separated by blank lines. We actually solved that problem yesterday. So what I'm going to do is just copy the code from yesterday that did the same thing, rather than going through it all again. So I'm going to day 5. So we'll open another editor on day 5. And the main.go yesterday had oh no, it wasn't yesterday. It was day 4. Sorry about that. I'm gonna close this. Try again with day 4. Boy, things are slow today. Streaming is getting expensive. So yeah, here's what I did on day 4 yesterday, or on day 4. I used regex to get me to split based on blank lines. So instead, I'm going to replace the main that I have right now with the one that I used on day 4. So if I save this, we're going to change the 4 to a 6. One of the nice things about Visual Studio is that you can set up multiple cursors and then type in the same thing for all of them. So in this case, I took the 4, I highlighted it, I hit Command D to highlight both 4s in successive rows, and now I have 2 cursors, and if I type, I'm going to be typing on both lines at once. So it's an easy way to make multiple changes instead of using search and replace. Okay, so what this is doing is it's taking and creating a regular expression which splits on new line followed by some number of blanks on that line, or possibly 0, and then a second new line. So I can read the whole file in, I can split it up based on new line, and then I'm going to get a collection of items. In this case, I'm not going to call it passports. I'm going to call it, what do they call it? Declaration form. We'll just call it declarations is a tough word in programming, so we're going to call it forms. See, and this is another place I could have used that. So I'm going to do it again just to show you. If I go double click this word and then Command D to highlight the other ones, and then I can do forms. I could also have right clicked on that and said change this variable, and then it does it in a smart way. It actually knows enough about the language to isolate the uses of it as a variable and replace those only. But it's the way I think so. Cheers, by the way. The sun's over the yard arm somewhere, so I'm drinking a beer. Here we go. So great. This is a good start. I'm just going to comment out this line, and we'll change the wording later. But we can write day 6 and take forms as our array of strings. Func day 06a of forms, which is an array of string, and it returns an int. And we need to, so now what that's going to be based on our input here. Oh, we should probably set up our input files. So here's our sample input. And they gave us the answer for the sample input. So that's why I like to use the sample input in these problems. So there's our sample input. I'm going to save that. And then here's the puzzle input for real. It's going to be a much bigger collection of data, and multiplied together it's going to give us an enormous number. So that goes into input.text. There we are. It's 2100 lines long, but that's fine. Go can handle that in its sleep. So let's start by reading this. We're going to read the sample data. Input sample. I called it input sample rather than sample input because then they sort together on my editor. I just like to do it that way. Save that. Now let's go back to filling this out. So what we need to do is for each value in forms, we need to split it up into a group of lines. And in this case, the lines are split by new lines. So we can do lines. Well, no, sorry. First, we're going to go through, iterate through each form. So for underscore comma f colon equals form in forms, form in forms. See, now I'm speaking another language. Colon equals range forms. So what happens when you write multiple programming languages? It can sometimes be confusing. Now, for each f, we're going to split it. So lines is going to be strings.split f, and our separator is new line. So here we are. Here's our set of lines. And, excuse me. So let's go back to the problem. Each line is a set of characters. And what we want to do is just iterate through the set of characters and add them to a string set. Now, we wrote a string set the other day too. So I'm actually going to copy this entire file and just use it because these guys seem to be happy about sets this year. We may start doing more things with sets as we go forward. And in fact, if you look in my GitHub, I once created a string set class, which is pretty complicated. I mean, it basically supports all the operations you would use on a set. And you know what? That's kind of an interesting thing, just for fun. Maybe we import it and we talk about using mods today. So if I go here, let's do that. And I'm gonna say go get, and then it's github.com. The module's name is github.com/KentQuirk. That's my name. / string set. And I'm going to get version 2 of the set. So I created this when I worked for a company a long time ago, and they made me, they allowed me to make it a public platform. That was one of the things I liked about that company, is they allowed me to open source stuff. So open source that class, and then, but when I built it, I gave it a couple extra features that were specific to the needs of that company that really aren't that useful in general. So what I did was, once I started turning it into a module after I'd left the company, I turned it into a module, but then I versioned it. So Go module versions are more interesting because, the point is that modules need to be backwards compatible. And if you ever change the backwards compatibility guarantee, then you need to version the module in the module name. And there's been tremendous amounts of virtual ink wasted on debating about whether this was a good idea or not. I've come to understand it, even if I'm not all that fond of it, because it's pretty hard to imagine a way in which it would work better without doing it this way. So what I'm going to do is I'm going to get version 2. And so I'm going to do that go get, and it's going to run out and go get that for me, and it just imported it, upgraded it. It's 201, came in, and you'll notice that my go mod was just modified here. And so now I have a reference to GitHub v2, which is at v02.1, and it's also telling me right now it's not used, but it will be in a moment. So now I can put in my import. Actually, let's just do, whoa, sorry about that. Mistyped. Let's just do something here. Set : equals new string set. I'm curious if this is going to come in by itself automatically, or if I need to preface it. That's right, I forgot how to use my API. String set.new. And there, see, it imported it for me. So here's the import. Why isn't it in my GoWad file? Yeah, it's weird. Sometimes, okay. So for this user, we're going to take a set, and we're going to take a string set, and we are going to add for a range loop over a string is probably the easiest way to do this. If I do a range loop over the string, then I can iterate and just check to make sure that the characters I'm iterating over are alphabetic characters, and then just add them to the set. So let's just do this. For underscore comma oh, well, see, I was going to split it and then iterate over each of the lines, but I don't actually have to do it. I can just iterate over F. If C is greater than or equal to A, let's turn this into an array of Rune. I think is what I have to do here. If and then and C is less than or equal to Z, so a string is an array of bytes, but it's also can be perceived as an array of runes. Now I can iterate over this. I think if I range over it, I'm getting bytes, unless I do it as an array of runes. The other way to do this would be to use explicit rune iteration, and there is a string strings has index rune, which is expensive. IF dot. I know there is. Well, I could turn it into a rune reader, and I could read a single rune at a time from a reader. I don't want to do that. I'm just going to just do it this way. Then I can see, this is easy if you just think of them as bytes. And then you can leave it as strings, and it's easy to manipulate. But in this case, the correct way to do it is not to treat them as bytes. The point of strings is that they may not be bytes. If you're dealing with localization, if you're dealing with internationalization, you have to iterate strings by the runes that are in them, because somebody might put emojis in them, somebody might put, obviously foreign characters, whatever. So you need to actually process runes. So I'm just gonna look something up, because it's been a while since I played with this, and now I just don't remember. So go string iteration by rune. Whoops, by rune. No, so range iteration is over the runes. Never mind. Okay, so I don't have to convert it to an array of rune here. I can just range over the string. Okay, I thought there was something like that, but I just didn't remember what. So now, iterate over the range of that, and C is a Rune. So that's why I'm using single quotes here, because single quotes defines the Rune. So since I have a Rune, I need to make, in order to add it to the string set, I have to add it as a string. So okay, string, I can just use a string conversion. I wanted to make sure that that was true. Alright, I can use a string conversion. So C is A and C is less than Z, then set dot add of string of C, and then when we are done, all right, so the day 6 collects a set of forms. Let's go back to the problem. The problem is add the set of counts, not multiply. Add the set of counts from all of these sets. So we're going to have a total out here. Total and for after we've done each thing, we can say total plus equals length, set dot length. And then we're going to return the total. Oh, it's not. Ah, there we go. So I think we have, so we set a total of 0. We iterate over each of the forms. For each of the forms, we create a string set. We range over the string corresponding to that particular set of strings. We add the items that are in the range of letters to add to the string set, and then we ask how long was that set, and then finally we return it. This is making sense to me. I think we should try it, see what we get for the sample data. So we're going to go run main.go, and it says 11 total was the number. That's wrong. So what do we do? Oh, I think it's wrong. Oh, it is. No, it is right. 11 was total. I thought it said 31. I don't know why. Oh, because it's 3 plus 3 plus 1. I somehow interpreted that as 31. All right. So 11 is in fact the right answer. So now we can try this data as on the real input. So let's go to input instead of input sample. And run it again. And 6,583 questions were answered. So that is the number that we should put in here and submit it. That is the right answer. So yay. Okay, so part 1 is solved. I'm going to have a sip of beer and get my voice back. Excuse me. All right, continue to part 2. Let's see what they have for us second half. Part 2. As you finish the last group's customs declaration, you notice that you misread one word in the instructions. You don't need to identify the questions to which anyone answered yes. You need to identify the questions to which everyone answered yes. So with the same data, we have to figure out how many people are in each group. Excuse me. So in the first group, everyone, all one person, answered yes to all 3 questions. In the second group, there is no question. So we have to count the number of individuals, and that's the number of rows. And then within each group, we have to count the questions for which the total number of answers for that letter is the same as the number of items, number of rows. So basically it's which letter occurs in every row. So, this time we did this, so we did it in a way that we did it using the string set feature that I had, which was like an easy way to have a set of strings. And we needed that. But now we need more than, we need a map. We need to go back and say, no, we should have done this with a map. The map would let us count the number of different lines in the set, and then oh wait, hold on a second. If we were to do this, so I think, okay, so there's an easy way to do that. So there's two tricks here. One possibility is to say we're going to store the data as a map of question ID, question letter, and a count. And so we go through each line in each group. And in fact, I called it F. I'm going to rename F to group. So for each group, each row is a person, and we can add all the questions. Basically for each person, we go through and we take each of the questions they answered and we increment the counter. And then we can look at the map and we can say which elements in that map have a count that is equal to the number of elements, the number of groups we process total. So we count the number of groups we process, and then we iterate through each map looking for those. However, we can also do this with sets. The way to do it with sets is we store a set for each person regarding which questions they answered. And then we intersect all the sets. And the only thing left in the set when we're done after an intersection. So like if person 1 answered ABC, person 2 answered ABD, when we intersect those, what we have left is AB. If the third person answered A and F, then when we intersect the result of our first intersection with that, the only thing left is A. So at the end, if we do intersect all of the sets that we have, then the result at the end will be only those values that are common to all people. And then we can look at the size of that set and return the size of that set. So the set length there. So since that's similar to what we already did for day 6A, I'm going to do it for day 6B. So we're going to copy day 6A to day 6B. And we are still going to total across all groups. So that's our total here, but that's fine. But instead of just iterating, doing a range over the groups, we're going to go back to the thing that we originally talked about, which was create a person for each group. So we're going to go for underscore comma person colon equals range. Oh no, we need to split the group. Sorry, we need to split the groups on lines. So people colon equals strings dot split of group on a new line. And now for person in range people. So now what we need to do is we need to create an array of sets for each group. So, or I'm going to call it a slice of sets. Guys, I tend to use the term array when I mean slice because I program in a lot of languages and I forget about Go sometimes. But a slice of sets. So let's create a slice of sets. So sets is make of string set dot string set. And actually we're going to do a pointer to it since that's what new returns for us. So we're making an array of pointers to sets. So for each person in the range of people, and then for each character in range of person. We're going to set this size of this set to length of people. And then we can just use this index sets of I. There we go, dot add. So now each person is going to get their own set in that. Oops, no they're not because that set hasn't been created. Each person will have to make a new set. We take this line and we move it because it doesn't belong here anymore. And we're going to add that person, and then when we're done with the range of person, then we do sets of I equal set. All right, so now that we have done that, we have a set, we have a collection of sets. We have a slice of sets. Each of those sets contains the votes of that one person, and then we're going to go and iterate that collection of sets and intersect them all together. And the resulting intersection, the length of that gets added to the total. So, now we're going to Oh, I didn't actually have to keep an array of those. I can make the intersection set on the way. By. So before, so one way to do this, like I said, is what I've done here is I've created an array of sets and I'm collecting all the sets and then it's going to go back and iterate over them. But in fact, we don't need that information more than once. So what I can do is I can keep an intersection set around. The only thing is the first time through, it's going to be empty. So we can't intersect a set with an empty set. That will be bad. That'll give us a null intersection, and we don't want that. So what we want instead is the first time through the loop, we're going to say, okay, well, just make the result set this one. And then the second time through the loop, we will intersect whatever we had against that one. So let's just do this. So instead of making an array of string sets, we're going to have an intersection set. And I'm going to make it nil initially. So it's going to be, let's just do a var intersection set, and it's going to be a pointer to string set dot string set. And then I don't need sets anymore, so I create the set for this person, and then at the end of it I just say if intersection set is nil, intersection set equals set, and that's all I need. However, if not, then intersection set equals intersection set dot intersection with set. So at the end of this, so now I'm building a set and then intersecting it with my collection, and so at the end of this I have all the values, all the questions that everybody answered the same. And instead of being set length, this is now intersection set length. Whoops. And then we can return that total. So all right, so let's go back to the sample input just to see if we get 6 like we're supposed to. I declared but not used. Whoops, you're right. I changed the way things are working, and now this should be an underscore. And I didn't notice the little squiggly line. See any more errors? No more errors. Okay. Six questions were answered the same by all group participants in Part B. So it seems like we got the right result here. So let's try with the actual real data. See what we get. Now this number is going to be smaller, obviously. So the first part was still 6583. That's just like we thought. And in this one it says 3290 questions. which is the sum of all the things. So let's just take a look at the data to see if it seems plausible. So in this one, for example, HKRFOL. So F is the same, O is the same, L is the same. So that's 3 on that one. You know, these are obviously much bigger. There's a lot of, you know, these are kind of randomly oriented things, and everybody's answering yes to a lot of questions. So I'm going to guess that this is actually not bad. See, like this, the 0, because there's nobody that answered the same. But anyway, all right, let's try. So the number we got was 3290. That is correct. We did it. All right. Well, that was pretty quick. We've been on for 45 minutes. Just for the fun of it, let's try and say, how would we do this in Python? Because we have a little bit of time, and this was pretty easy. I'm actually kind of hoping these are going to get more interesting as they go. I remember Advent of Code having some problems that solve really quick, and some problems that were actually quite challenging to solve. I haven't seen a quite challenging one yet this year. I'm hoping we're going to see some more problems that make us think a little harder than this. But hey, we are what we are. So let's try doing this in Python. So, before I do, I'm going to check this code in. So let's check the Go code in. So we have Go mod. So let's just take a look. Go mod now has this. Go sum now actually has data in it this time, which is basically these are the things that are being pulled in by string set, and there's a bunch of like test code and things like that supported by that. Excuse me. And then so let's just check all these in. Go mod, go sum, go input sample.txt, input.txt. Solve day 6 in Go. Put that up to GitHub. All right, we're good. Now let's try the Python version. Whoops, I'm in the wrong world here. Wait, why is this telling me? Oh, because let's take a look at what go mod tidy does. Go mod tidy. Oh, because it said it was indirect when it first installed it because I hadn't used it yet. Now I've used it, it's no longer indirect. So see if go sum gets any better now. Oh yeah, go sum changed too. So let's add go.star get status git push, git commit dash m there we go. All right. Now that's more correct. Now we can close these things and go look at the Python version. So, all right. So first we got to solve part A. So part A. So now we've read the data. I did a read lines in my original Python input thing, but actually I think the strategy I used in Go is actually better. I'm going to read all the data as one big blob and then split it using Python's equivalent of a regular expression split. So, oops, Python 3, split, 7 results. We're going to look at the regular expression version of split. So split takes a pattern, splits a string by occurrences of pattern. Alright, this thing that is the pattern that's being split is the separators. So we can say, we're going to say import, I'm going to import RE, and then we're going to say re.split. So if I were using this more than once, then I might compile the pattern and then call split based on the compiled pattern. But in this case, we're just calling it once, and so we can just do it with the RE function that's built in. So we can do, we're going to split by, the pattern is new line, and any number of blank spaces or tabs, including 0, and then another new line. Whoops. It needs a backslash. Sorry. And so pattern data, and I don't need to do anything else. That is going to be the groups are equal to the split of that, and then let's define day 06A is taking a bunch of groups, and how did I word it? We're going to make this an F string, and alright, in case that's new context to you, an F string is a string that does interpolated expression evaluations in the middle of the string. You're starting to see this in a lot of languages. Python added it at sometime in version 3, 4, 5, or 6. I've forgotten which one. And I think it was 6. So we're going to say day 06A of groups. And notice the syntax highlighting was the curly, because it's an F string, the syntax highlighting said, oh, this is actually normal Python code here. If I deleted this F, you'll see that the syntax highlighting will change to just be embedded string, but it's an F, so it's going to do that call. And day 6a is going to say, so I have a bunch of groups, and I've actually forgotten what we were trying to do with day 6a. For each group, we're going to make a set of the so for each group, we just need to accumulate the total number of unique answers in each thing. So we're going to say for each gene groups, S equals a set for C in G, we're going to S dot add of C, and then when we do, so we add C, and then we are going to, at the end of that, we're going to say for each group. All right, that's right, yeah. So we need a total equals 0, S dot add C, total plus equals len of S, return total. That should give us 11 when we print it out. So let's do this and say Python 3 main.py. Well, that's wrong. And also I forgot to do input sample. So we're going to do input sample first of all. So it gives 14 instead of 11. Oh, because I forgot the conditional about whether it's in the range of A to Z. So if C in, I'm just going to A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So if C is an alphabetic letter, then we add it. That may not be the fastest thing to do, but there we go. Now we get the right answer. And so now we can go back to input and make sure that we still get the right answer. 6583, and I'm pretty sure that was exactly the value we had before, 6583. Okay, so that's that's part 6A. And part 6B, so let's do 6B. We still have a total. We still have a set of groups we're going to iterate over, but we need to iterate over the lines in the group. So we need to split lines, and I'm trying to remember so string has a split function as part of it using a separator, and it actually has a split lines, and we can set keep ends to false because we don't need or want the ends of the lines. So for 6B, we are going to for person in sorry. for person in G dot split lines of keep ends equal. So we create that set. We create a set for that person. I don't think I need this line, so I'm going to comment it out. For C in person, add, because I've now not keeping the end, so all that we have left is the letters. So I'm going to be confident and eliminate it. For C in person, add to the set, and then after we've done that, if no, that's interesting. I can't make intersection set equals the set. I have to make it a null. Wait, does Python have null? I don't remember. No. No. Null, that's right. Why didn't it highlight it? None. Thank you. Too many languages. Okay, great. Thank you very much. There we are. Okay, now, if intersection set is none, then intersection set equals S else intersection set dot intersection set equals wait, frozen set has intersection. Do I have to do this with a frozen set? Or is it an operator? Class set. Oh, I just say intersection of sets. Intersection set equals intersection of oh, binary syntax is and. Oh, really? Fascinating. Oh, set and. Yes, thank you. That's what I should have known that. That's what I get for not paying attention. And then total equals length of, not S, of intersection set. And then B okay, just try that. 3290. I'm pretty sure that was also the right answer. 3290. Yeah. Okay. So we did it. Now it just occurred to me as I was doing that that this may be. I'm just gonna, for fun, do this with a generator approach, maybe. Def day 06A1. I just want to think about this. Is this a valuable way to do this? S equals set. And you could say it's not worth it. I was just trying to see whether there was it would be faster or cleaner or more obvious to do this with generator syntax, but I don't think it is. So I'm just going to stop here. I'm going to push this up to GitHub. main.py. Stick that in. All right, so I think that will do it for tonight. I have solved part 6 of Advent Code. 2 pieces, done them in Go and Python. The key to this one is just knowing that you can do things with sets. They're pretty clean, pretty quick. Go doesn't have a native set the way Python does, so you have to be a little trickier. I got away with it because I had a string set already created. A couple of days ago I did it with an explicitly defined set, which was a map of string to none, or to empty struct. But there's 1,000 ways to solve this problem. I'm trying to show one person's thinking aloud while I go and do it. So I hope this is interesting to you. Happy to have you on the stream, and hope you have a great day, and please come back tomorrow and we'll do another one. Have a good night, everybody. Yeah, there we go. Look me up, tap the follow button. There's all those things you can do. And I'll see y'all later.